Nestled away along McPherson Road and Aljunied Road is an industrial estate, housing buildings like the Sindo Industrial Building, Genting Warehouse Complex, Chevalier House, and more. When my team first visited the site, we found that most buildings in the area were generally old and poorly maintained. Though these buildings are rich in history and important to architecture, some may argue that they have outlived their utility. We also noticed that there were many construction projects ongoing, as well as a few newer buildings. Given the newly constructed buildings that have started enveloping the industrial estate along the Pan Island Expressway, my team saw an opportunity to jump on the rising trend of green industrial buildings and design a building that is not only functional and sustainable, but aesthetic as well. The site we've chosen is URA Zone B2, set for industrial use. However, we intend for it to be mixed use, catering to a wide array of office workers and businesses. The site sits along Kallang Way, with cars coming in from PIE, McPherson Road and Aljunied Road. The site is also a 5-minute walk from Mahta MRT station and is less than 100 meters away from the nearest bus stop, which is very convenient. Using Ladybug and Grasshopper, we were able to do a shadow analysis of the location site and confirm that our building will be able to receive ample amounts of sunlight. We also used this data to calculate the total shadow area, which we used as one of our fitness values in Octopus to generate our building design. Incorporating passive green design is a way for us to reduce the building's overall energy consumption. One such way we could achieve this was through generative design. As such, when it came to our building's design, we wanted a base design that could be parametrically altered easily. After much discussion, the design team came up with a rough model which looked something like this: a building made up of blocks of varying dimensions, angled in different directions, and stacked atop one another, with each block serving different purposes such as showrooms, warehouses, and offices. After which, we used Grasshopper to script our model and included parameters which were inputted into Octopus. We also used Grasshopper to build our geodesic hemisphere that sits in the middle of the built area. Once we had our Grasshopper script, we inputted the parameters into Octopus, a multi-objective optimizer, to generate a structure that both maximizes shadow area and building surface area. This maximizes the amount of ambient natural light that can enter the building while reducing heat gain as the building casts shadows upon itself. With the help of LE3D, we were able to run a wind simulation on our base geometries and found that our central building can greatly benefit from natural ventilation. Therefore, we decided to add a central atrium to promote natural ventilation throughout the building while also allowing wind to flow through. Now, let's take a look at some key features of the building.